Hello, good afternoon. Now I would like to introduce about myself. This is Venkatesh. Now I am going to give presentation regarding to the first unit of data structure. In this unit we are going to discuss about three things. The first one is called as asymptotic notation. Second one is arrays. Third one is linked list. So first I am going to give the demonstration regarding to asymptotic notation. Uh, See here, to solve any particular problem, we need to develop the solutions. Maybe the same problem having several solutions. Maybe the same problem having several solutions. Among these several solutions, we need to select the best solution. To select the best solution, or how we can say that the solution or an algorithm is best algorithm, is algorithm is nothing but already we know about that step-by-step procedure which is to solve particular problem. If maybe the same problem having several solutions, we need to select the best solution. How we can identify the solution is the best solution or algorithm is the best algorithm? Based on the two factors, one is time complexity and the next one is space complexity. Time complexity represents the amount of time that is required for executing an algorithm. Space complexity is represent the amount of space that is required for storing that algorithm. For any algorithm, if the time complexity and the space complexity are very less, we can say that that algorithm is efficient algorithm. So by using these two factors, time complexity and space complexity, we can decide the algorithm is best algorithm or not. Then now here to decide the algorithm is the best algorithm or not, we can use time complexity and space complexity. But the time complexity of an algorithm is represented by using some symbols or by using some notations. That symbols or notations are nothing but asymptotic notations. I hope you understand what is the definition for asymptotic notation. These are the symbols or representations that can be used for representing the time complexity of an algorithm. Then to represent the time complexity of an algorithm, we can use three types of notations, three types of asymptotic notations. Actually the time complexity of an algorithm is represented in three ways. That is upper bound of time complexity, lower bound of time complexity, average bound of time complexity. So here I have used some notations, that is one is omega notation, theta notation, little omega notation, big O notation, theta notation, little omega notation, little big O notation. These are the five notations that can be used for representing the time complexity. But actually we can use only three notations. One is omega, next one is big O, and another one is theta notation. In the title itself we have the demonstration. Next, big O notation. When we can use this big O notation is, see here, big O notation, it represents upper bound of time complexity. It represents the upper bound of time complexity. Here already we have the formula C1 g of n is less than or equal to f of n is less than or equal to C2 g of n. So here actually first we have discussed about the theta notation. We can pronounce it as a theta notation. What is the theta notation can be used for representing the average time complexity. Average time complexity means here maybe for some algorithms the maximum amount of time and minimum amount of time both will be same. Here already in this formula we have, that is our f of n is lies in between C1 g of n and C2 g of n. Here C1 g of n is the lower bound, f of and C2 g of n is the upper bound. By seeing that graph representation also we can understand that here the time is lies in between the minimum amount of time and the maximum amount of time. So the minimum amount of time, if the time is lies in between minimum amount of time and maximum amount of time, that is denoted by theta notation. So because of that reason it is the entire graphical representation regarding to the theta notation. It represents average time complexity of an algorithm. Then next we can go for next slide, that is next omega notation. Omega notation represent lower bound of it represent big O notation. Okay, big O notation, it represent upper bound of time complexity. By seeing that graph itself, we can understand that here g of n is always greater than or equal to f of n. G of n is represent upper bound. Always it must be greater than to f of n. Upper bound is nothing but it represents the maximum amount of time is required for executing particular algorithm. That is nothing but that is denoted by big O notation. Next, go for omega notation. Already, as I have given a message, totally the time complexity is represented in three ways. That is the upper bound, lower bound, and average. Already, average is denoted by theta notation, and upper bound is denoted by big O notation. And the next one is nothing but omega notation. Omega notation, it represents the lower bound of a time complexity. What do you mean by lower bound of a time complexity? It represents the minimum amount of time that is required for executing particular algorithm. Here we have f of n is equal to omega of g of n, that represent at this point n naught, the both functions f of n and c into g of n will be same. Here c is nothing but some constant value that always greater than 0, and here n naught represent inputs, that is also must be greater than or equal to 1. Why? Because input is always greater than or equal to, we have to give at least one input. So this, because of that reason, it is always greater than or equal to 1. So this is entire introduction regarding to the asymptotic notation that are used for representing time complexity of an algorithm. Next we can go regarding to relationship between all these three notations. First one represent average time complexity, second one represent upper bound, that is big O notation, and the next one represent omega notation. First graph represent average time complexity, second graph represent upper bound, and the third graph represent lower bound. Upper bound means maximum amount of time, lower bound means minimum amount of time. So this is entire demonstration regarding to the asymptotic notation. As already I have given a statement, here we are going to discuss about three topics. Under that, first one is asymptotic notation, we have completed now. Then we can go for next one is arrays. By arrays, what do you mean by an array? So actually by using variables we have the drawback. What is the drawback is, by variables we can store only one value at a time. If you want, we can store more than one values by using more number of variables. If the program having more variable declarations, it will take more amount of time. To overcome that drawback, we need to go for another feature, another nice feature which is supported in C language, which is called as arrays. Array can be defined as collection of elements which are belongs to similar data type. And all these array elements must be stored in continuous memory. What do you mean by continuous memory? If the first element is stored in 1000 address, second element must be stored in 1002, next 1004. If it is, for example, it is the integer data type. So finally, array is nothing but it is a variable where we can store more than one values at a time, and these elements must be stored in continuous memory. That is the introduction regarding to arrays. Next thing we are going to discuss about that. See, in the data structure subject, as a faculty of data structure subject, we are going to give the demonstration in one standard notation. That is, every data structure we are going to discuss with four common points. One is the definition, and another one is representation of definition of data structure, representation of data structure, and operations of data structure, applications of data structure. So here data structure is nothing but data structure can be defined as collection of organized data. Collection of organized data is nothing but when we can say the data is called as organized data. If the data is represented in one standard notation, that may be sequential or maybe hierarchical manner or maybe tabular representation, that is nothing but hierarchical, that is nothing but standard notation or standard representation. Then if the data is represented in sequential manner or hierarchical manner or a tabular representation or graphical representation, then we can say the data is called as a standard structure or organized data. Collection of that type of organized data is nothing but data structure. Next thing, data structure can be classified into two types. One is linear data structure and another one is non-linear data structure. Now our topic arrays comes under linear data structure. In linear data structure we have several data structures. One is arrays, linked list, stack, queue. In non-linear data structure we have several data structure, trees, graphs, sets, tables. So these comes under non-linear data structure. First we are going to discuss about array. Already I have given a definition for an array. Then the next thing, representations of an array. Already I have given array elements are stored in continuous memory. Here the first location is used for storing first element, second location is used for storing second element. So here continuous memory means if the first element address is 1000, second one 1002 already have given. So this is nothing but memory representation. For example, if we have A of 5, A of 5 means here maximum we need to store 5 elements. That is integer data type 5 into 2, 10 bytes of memory is allocated at the time of compiling our program. And this memory is called as a static memory. Later we'll discuss what do you mean by static memory, what is the drawback by using this static memory. Then we can go for next thing. Already I have given, so far I have given definition for an arrays. Next one I have given representations of an arrays. Then now we are going to discuss about operations that can be performed on arrays. So we can perform operations is nothing but several functionalities that can be performed on particular data structure. What are the different type of functionalities that can be performed on data structure, that is arrays? One of the operation is the traversal operation. What do you mean by traversal? The process of visiting each and every element in array is called as a traversing. Then go for searching. What do you mean by searching? The process of identifying a particular element is available in the list or not is called as searching. Then go for the insertion operation. The process of inserting or adding a new element into the array is called as insertion. But here you have to remember when the insertion is possible. If we have some empty location in an array, then only the insertion is possible. Inserting a new element at the last position, that is very simple, simply by writing a single statement, that is a new element, that is last position is equal to new element. By writing like that, we have done insertion. But insertion at the last position is not at all difficult, that is very simple by writing a simple statement. But here we have some complication if we want to insert a new element at any position except the last position. So what we need to do is, here we need to perform the shifting mechanism. By using shifting mechanism, we need to shift the elements to end position. Why? Because we need to make the empty location a location at which we want to insert the new element. So that is the story regarding to insertion. And deletion is nothing but the process of deleting an element from the array. See, at the time of insertion, maybe if the array having only the 4 elements, by performing insertion the array is having 5 elements. Regarding to the deletion, if the array having 5 elements, by performing deletion operation, it is having only the 4 elements. Then we can go for next operation, that is sorting. See, what do you mean by sorting? In the name only we have the explanation. The process of arranging the elements, array elements in logical order. Logical order means that may be ascending order or maybe descending order. I hope all of you are very familiar with that ascending order and descending order. Ascending order is nothing but we can move from small to bigger. Descending order means we can move from bigger to smaller. See, as a sorting of array elements, this operation is applicable. This operation is implemented in our real life. Regarding to the telephone directory, there the names are sorted. The customer names are sorted according to their names. So that is one of the real-time application where we can use the sorting mechanism. Then next go for the merging. What do you mean by merging is nothing but the process of combining two arrays into a single array is called as merging or not. Suppose consider this array. In this array I want to search B element. So we need to perform searching operation is also in a sequential manner. Start with either first position or start with the last position. So first we need to, suppose I want to search B element. First we need to compare our searching element with A. Why? Because it is the first element. A is equal to B. Here it is not satisfied, not matching. Then we need to go for second matching of second element. B is equal to B. Our searching element is B and then the second element is B. Both are matching. Because of that reason, both are matching. Here searching is successfully done. Why? Because our searching element is found. So the searching element is B is available at first position. That is the searching operation. And traverse operation is nothing but visiting each and every operation, visiting each and every element in the array. First we need to visit A. Visiting is nothing but simply we can display that elements. Simply display A, first to display A, then display B, then display C, then display D, then display E, then display F. So this is traversing of an arrays. So far I have discussed several operations, which are performed on arrays. There the first one is searching completed, traversing completed, insertion completed, deletion completed. And the next remaining operation, that is sorting. Sorting is nothing but the process of arranging the elements in logical order, either ascending order or descending order. So here we need to compare the first element. Here we need to compare the first element with the second element. If the second regarding to ascending order, suppose if you want to arrange the elements in ascending order, so what we need to do is First we need to compare the second element with the first element. If the second element is smaller than to the first element, we need to interchange the two elements. If the second element is greater than to the first element, we need to keep same as it is. Then we need to compare the third element with the second element. Third element with the second element. If it is less than to the second element, interchange the two. If it is greater than, keep keep it as same. So we need to repeat this comparison mechanism until we can compare with the last two elements. By comparing last two elements, we can say that the array elements are sorted. If the elements are sorted, we can say that there the sorting operation is performed on arrays. So every time here we need to compare. In sorting here, we need to compare the adjacent elements. Adjacent element, first element, second element with the first element, third element with the second element, fourth element with third element, fifth element with the fourth element, and so on. So this is the demonstration regarding to sorting operation and arrays. Next we can go for, that is the same. See here the PPT. In first array, it is one real time example I have taken today, explain about the sorting mechanism. Here I have taken around 10 peoples or 10 persons. Among these 10 persons, some of are very small, some of are very larger than first one or larger than third one, maybe like that. Here the peoples are arranged in an order. An order is nothing but not in a logical order, not in a ascending order or not in a descending order. Then what is the, by applying sorting operation on these 10 peoples, what is the result we got? We got the result like that. Now you can see here the peoples are arranged in, the peoples are placed, the peoples are stand in logical order, that is ascending order. That is first one is very smaller than second one, then second one is smaller, second person is smaller than to third person is smaller than to fourth person is smaller than to fifth person is smaller than to sixth person. So this is nothing but a sorting mechanism. Then here we have several sorting techniques are there, but for example purpose I have displayed only the selection sorting. In this selection sorting, what we can do is we can select the first smallest element. For example, here we, in our hand we have an array with 5 elements. Among these 5 elements, now first we need to select the first smallest element, replace the first element with the first smallest selected element. Then we need to select the second smallest element, replace the second smallest element with the second element. Then we need to select the third smallest element, replace the third smallest element with the third element. Then we need to select the fourth smallest element, repeat so and so mechanism, repeat this mechanism and in n minus 1 steps. Here again we have a new term, that is n. N is nothing but number of elements in the array. See, if array having 6 elements, then we need to perform selection sorting in 5 steps. That is nothing but selection sorting. Next we can go for, this is already have given a mechanism. In total selection sorting, how many number of comparisons are required? N into n minus 1 by 2. And here already I have given in starting topic, that is asymptotic notation, that is used for representing the time complexity of an algorithm to decide that which algorithm is best algorithm. So here the selection sort time complexity is big O of n square. And next bubble sort is there, selection sort is there, insertion sort is there, merge sort is there, heap sort is there, shell sort is there, radix sort is there. Like that several sorting techniques are there that we will discuss in future units, no problem regarding to that. You can remember only here what is sorting. Arranging the elements in, arranging the elements of an array in order, either logical order, either ascending order or descending order. Next, already as given several sorting techniques are there. Next one is insertion sort. In insertion sort, what we can do here is, see, first element we can keep as same as it is. Then we need to think about the second element, where we need to insert the second element. We can insert the second element either before the first element or after the first element. When we can insert the second element before the first element, if the second element is, I am talking about only the ascending order, that is smaller to bigger. If the second element is smaller than to the first element, we need to insert the second element before the first element. Then we need to think about the third element. We can insert the third element either before the first two elements or after the first two elements or in between the first and second elements. So we need to do the comparisons. First we need to compare with the first element, then we need to compare with the second element. So total 2 comparisons are required to insert the third element. If it is greater than to the first element and greater than to the second element, then we need to insert after the first 2 elements. If it is only greater than to the first element and less than to the second element, we can insert in between the first and the second elements. If it is greater than to all the two elements, then we need to insert after the two elements. I hope you understand the algorithm regarding to insertion sort. So next we need to think about where we need to insert the fourth element. See, you can guess fourth element is inserted in different locations. Either the first one is either before the first three elements, after the first three elements, in between the first and second, in between the second and third. When before the first three elements. If it is smaller than to first three elements. When we can insert the fourth element after the first three elements. If it is greater than to all the three elements. When we can insert fourth element in between first and second. Greater than to first, less than to second. When we can insert in between second and third. Greater than to second, less than to third. Then we need to insert in between second and third. So this is the entire demonstration regarding to insertion sort algorithm. Here you can see already I have given, here also we have the different 10 peoples are there. How we are going to insert is, first we need to pick up the second person. If second person is greater than, second person is larger than first person, we can keep that same as it is. Then we can pick up the third person. Then we need to compare the third person with the first person. If the third person is larger than to the first person, then we need to compare the third person with the second person. If third person is larger than to the second person, then we need to place third person after the first two persons. Then we need to think about where we need to place the fourth person. To place the fourth person, first we need to compare the fourth person with the first person. If fourth person is larger than to the first person, we need to compare fourth person with the second person. If fourth person is larger than to the second person, we need to compare fourth person with the third person. If fourth person is larger than to the third person, then we can understand that we need to place, we need to insert, we need to arrange the fourth person after the first three persons. We need to repeat the same demonstration, same mechanism, and for arranging all the elements in given array. Then regarding same procedure we need to repeat for fifth person, sixth person, seventh person, eighth person, and so on. So this is the demonstration or algorithm regarding to insertion sort. See, next, go for next one. Yeah, so already as I mentioned, that is selection sort and insertion sort. Selection sort and insertion sort. Insertion sort we have compared, we are thinking about the second element and the third element, that is the algorithm regarding to insertion sort. So like this we have several sorting techniques, but it is not the correct time to discuss about all the sorting techniques. In future class, in future we'll have separate unit for this. Okay, leave over that. This is the entire story regarding to sorting operation on arrays. I hope you understand several operations we can perform on arrays, and I have discussed some operations, that is searching operation, deletion operation, insertion operation, traverse operation, sorting operation. All these are the different type of operations that can be performed on arrays. Then next, so here already I have given, that is here we have taken in array half of the elements are already sorted. Then we need to think about second half of the element. That second half of the elements are also arranged in sorting manner, arranged in sorting or arranged in logical order by using the same insertion sort algorithm. And next we can go for, so this is entire demonstration regarding to arrays. Next we can go for, as I have given instruction, we need to discuss about totally three topics: asymptotic notation, arrays, and linked list. See, before we are going to discuss about the linked list, first we need to discuss about why we want to go for linked list. What is the need to go for linked list? See, in our real life also, if you want to do any work, there must be a strong reason. See, here already I have mentioned data structures are classified into two types. One is linear data structure and another one is non-linear data structure. Leave over the non-linear data structure, later we'll think about the non-linear data structure. Right now I am going to discuss about only the linear data structure. In the linear data structure we have four types. One is arrays and another one is linked list. See, arrays comes under linear data structure. Now the linked list is also comes under linear data structure. See, already we have studied about the arrays, why we want to go for linked list. By using arrays we have several drawbacks. To overcome the drawback only we can go for linked list. First, I would like to discuss about what are the drawbacks by using arrays. By using arrays, see, already I have given array elements are sequential manner. Sequential manner means the first drawback is we can't access the elements which we want from an array. Suppose I want to access directly third element from the array, it is not possible. To access the third element from the array, first we need to access the first element, then we can access the second element, then only we can access the third element. Directly I can't access in single step, I can't access third element from the array. That is the fundamental drawback by using arrays. And the second fundamental drawback is there, second important drawback is there by using arrays. Sorry, what is that second drawback is, in arrays, whenever we can take for example some int of 5 means, here the memory is allocated for 5 elements, for one element 2 bytes means total 10 bytes of memory is allocated. Here the thing is, memory is allocated, that already we know everyone, from starting onwards we have observed that. But when the memory is allocated, at what time the memory is allocated? The memory is allocated at compile time. See, if any memory is allocated or created at the compile time, we can say that the memory is called as a static memory. Regarding to arrays, the memory is allocated at compile time by the compiler. Because of that reason, we can say the memory is called as static memory. Static memory means, in the name only we have the explanation, that is constant memory. What do you mean by constant memory? See, how we can say array memory representation is the static memory is, suppose here we have created memory for 5 elements. Whenever we can execute the declaration statement, by default 10 bytes of memory is allocated. Suppose the 10 bytes of memory is required for storing 5 elements. Suppose I want to store only, can we store only 3 elements in this array? Yes, we can store. We can store 3 elements. If we can store 3 elements, there we have the drawback. What is the drawback? Already memory is allocated for 10 bytes, but we have stored only the 3 elements. For storing the 3 elements, actually 6 bytes of memory is sufficient, but unnecessarily we have allocated 10 bytes of memory. Means that is exceed 4 bytes of memory is wastage by using the arrays mechanism. So another fundamental drawback is memory is waste. How we can say that memory is waste? If we are trying to store less number of elements than the array size. We are trying to store less number of elements than array size. At the time memory is waste. If we want, suppose here we can store only maximum of 5 elements. Suppose I want to store 10 elements, or I want to store 7 elements. To store the 7 elements, actually 14 bytes of memory is required. But here the memory, we have only the 10 bytes of memory. We can't extend the 10 bytes of memory to 14 memory. That is the fundamental. That is, if you want to store 7 elements, that is more number of elements than the array size, at the time memory is insufficient. So totally I have given another 2 fundamental drawbacks in addition to the sequential memory. What is the another 2 fundamental drawbacks is, one is memory insufficient and another one is memory wastage. So memory insufficient and memory wastage. When the memory wastage, if we are trying to store less number of elements than the array size. When the memory is insufficient. When the memory is insufficient, that is if you are trying to store more number of elements than array size, at the time memory is insufficient. To overcome these 3 fundamental drawbacks, we need to go for another feature of C language, which is called as linked list. See, in the title only we have the demonstration. That is, what do you mean by linked list? Linked list. So actually here you see, first I have taken linked list. Why I have taken here means we have not the spelling mistake, sorting mechanism. Then here we have several sorting techniques are there, but for example purpose I have displayed only the selection sorting. In this selection sorting, what we can do is we can select the first smallest element. For example, here in our hand we have an array with 5 elements. Among these 5 elements, now first we need to select the first smallest element, replace the first element with the first smallest selected element. Then we need to select second smallest element, replace the second smallest element with the second element. Then we need to select the third smallest element, replace the third smallest element with the third element. Then we need to select the fourth smallest element, repeat so and so mechanism. Repeat this mechanism in n-1 steps. Here again we have a new term, that is GAN. Next we can go for, this is already have given a mechanism. In total selection sorting, how many number of comparisons are required? N into n-1 by 2. And here already I have given in starting topic, that is asymptotic notation. that is used for representing the time complexity of an algorithm to decide that which algorithm is best algorithm. So here the selection sort time complexity is big O of n square, and next bubble sort is there, selection sort is there, insertion sort is there, merge sort is there, heap sort is there, shell sort is there, radix sort is there. Like that, several sorting techniques are there that we will discuss in future units. No problem regarding to that. You can remember only here what is sorting. Arranging the elements in arranging the elements of an array in order, either logical order, either ascending order or descending order. Regarding to node, see here in this PPT consists of a linked list consists of several nodes. Each node consists of a data part and a link part. Already I have given, and don't get the confusion here. In this data part we can store data. In this link means it is pointing to somebody. So link field is used to store an address of next node. For example, see here it is, you can take, okay, then go for, I want to give this node a demonstration with one example. Okay, use of linked list. Use of linked list is nothing but a linked list can be used in what areas? Linked list can be used in different areas. In that, the first one is in our real life we are playing chess game. That is, chess game is defined by using some linked list mechanism. And the next one is some general problem solver, artificial intelligence. In artificial intelligence we can perform inference. I hope you understand what I mean by inference. The process of defining solution to the new thing from existing knowledge. In our hand we have some existing knowledge, and in other hand we have some new question. We need to give answer to that new question by using this existing knowledge. That is called as inference. That type of inference is implemented by using linked list mechanism. So this is different applications or uses of linked list. And the next one is advantages of linked list. So what are the advantages of linked list? Already I have given. You must remember one fundamental. Whatever it may be, the drawbacks are there by using arrays. All the drawbacks will be considered as advantages for linked list. There is the sequential memory. Here the memory is dynamic memory. There array size is fixed. That is 5. More than 5 we can't insert. We can't take more than 5 elements. Here we can take how many number of elements if you want we can take, how many number of elements if you want we can delete, how many number of elements if you want we can insert. And one more fundamental advantage by using the linked list is, already I have given presentation by taking an algorithm for insertion and deletion operation on arrays. At the time maybe we have some little bit confusion. We need to shift, how we can shift, why we want to shift. Like that we have some confusion. That type of confusion is overcome in linked list. In the linked list we can perform insertion and deletion operations very easily and efficiently when compared to the arrays mechanism. And many complex applications can be handled, can be solved by using linked list. And then go for another one. By using linked list also we have some drawback. Why we have, how we can say we have the drawback by using linked list is, linked list is collection of nodes. Node having two fields. It having two fields means automatically it will require more amount of space. And it is, if you want to see, if you want to access any particular node, it is somewhat little bit confusion and a little bit time taking process in linked list. See, actually we can't say that is the drawback. The fundamental drawback, it will require only the more amount of time. That is the fundamental drawback by using linked list. See, already I have given, whether you have remember or not, linked list is collection of nodes. Every node is having two fields. Here we have node that are having the two fields. One is the left side field, right side field. Left side field is used for storing the data, right side field is used for storing the address of next node. See this example. In this example I have taken a linked list with 3 nodes. One is 70 node, 80 node, 90 node. And don't think like that. Here we need to take the node values in ascending order like that. Whatever it may be, if you want you can take. Here 70 is used for storing the, in the first node we have the 2 fields, second node we have the 2 fields, third node we have the 2 fields. In the first node, in the data field we can store 70, and here in the first node we have, in the link field we have the 200. I hope you understand what is the 200. As I have given a message, this is used for storing or is used for pointing to the address of next node. Second node, 80 node is available at which address? 2000. That 2000 is stored in link field of first node. By storing that 2000 in link field of first node, we have the connection in between, we have the link in between 70 node and 80 node. Until unless we can store 200 address in link field of first node, the connection should not be established in between 70 and 80. Similarly, go for the third node. May I know what is the third node here is 90. Now, in this 90 node is available at which address? 300 address. See, in the 80 node, link field is filled with 300 node, 300 value. The 300 represent not the normal value, it represent an address of 90 node. So until unless we can store 300 address in link field of second node, that is 80, then only the connection is established in between 80 and 90 node. And I hope here you can observe that in the last node, may I know here what is the last node is 90. In the last node also we have the two fields 90 and null. The link field of last node is filled with null. Why? Why? Because after the last node we can say 90 node is the last node. How we can say 90 node is the last node? Further there is no another nodes. Because of that reason the link field of last node must be filled with null. By seeing that null we can understand that oh, it is the last node. So finally here the linked list is represented by using three nodes. Already I have given linked list is collection of nodes. Here the linked list is represented with a collection of three nodes. Second node address is stored in link field of first node. Third node address is stored in link field of second node. So that is the entire demonstration introduction regarding to the linked list. 10 and 20. To insert this new node in between 10 and 20, very simple mechanism. What we need to do? Simply we can adjust the links. We can store this new node address 700 at the link field of 10 node. Actually in the link field of 10 node, in our given linked list, what we have 200. Now we need to, in place of the 200, we need to store 700. By storing that 700, we have the connection in between 10 and 99. Still we need to do some more adjustment. What is that another adjustment? After the 99, we need to place 20 node. 20 node address is 200. Now we need to place the 200 in link field of 99 node, that is a new node. By storing that 200 in link field of 99 node, we have the connection in between 99 node and 20 node. So now initially the linked list having only the 3 nodes. Now the linked list having, by performing inserting a new node, the linked list having totally 4 nodes. So like that we can establish the connection. By adjusting the links itself, we can perform the adding or insertion operation in linked list. Next, omega notation. Omega notation represent lower bound of, it represent big O notation. Okay, big O notation, it represent upper bound of time complexity. By seeing that graph itself, we can understand that here g of n is always greater than or equal to f of n. G of n is represent upper bound. Always it must be greater than to f of n. Upper bound is nothing but it represents the maximum amount of time is required for executing particular algorithm. That is nothing but that is denoted by big O notation. Operation on linked list. Then the next thing, like that, in this sense only we can say that the deletion and insertion operation are performed on linked list very easily and efficiently. Now the next thing we are going to discuss about that, what are the different types of linked list. Based upon the number of link fields in a node of linked list. See, here we have maybe little bit confusion. Based on the number of link field in a node of linked list, the linked list will be classified into 4 categories. One is single linked list, another one is double linked list, next circular linked list, next one is doubly and circular linked list. What do you mean by single linked list? A single linked list is nothing but every node in this single linked list must be having only the one link. That link is used for storing address of next link. And double linked list is nothing but in this double linked list every node is having 3 fields. One is node field, another one is back field, and another one is next field. Back field is used for storing address of previous node, and next field is used for storing address of next node. Data field is used for storing data or information that is belongs to any data type. And here we have another terminology, circular linked list. In the circular, you see in the normal linked list, the last node, the link field of last node is filled with null. But in the circular single linked list, the last node link field is must be pointing to the first node. That is, these are then the linked list is represented in circle notation, circular format. That is called the link field of last node is filled with the address of first node. That is circular single linked list. Next, the back field of first node is pointing to the last node, and the next field of last node is pointing to the first node. Then we can say that the double linked list is in circular. That is called as a double and circular linked list representation. Okay, single linked list already I have given. Here we have only the two fields. One is information and another one is next. Information is used for storing data, any type of data. Next is used for storing an address of next node back by using linked list. See, already I have given, whether you have remember or not. Linked list is collection of nodes. Every node is having two fields. Here we have node that are having the two fields. One is the left side field, right side field. Left side field is used for storing the data. Right side field is used for storing the address of next node. See this example. In this example, I have taken a linked list with three nodes. One is 70 node, 80 node, 90 node. And don't think like that. Here we need to take the node values in ascending order like that. Whatever it may be, if you want, you can take. Here 70 is used for storing 10 and 20. To insert this new node in between 10 and 20, very simple mechanism. What we need to do? Simply we can adjust the links. We can store this new node address 700 at the link field of 10 node. Actually in the link field of 10 node, in our given linked list, what we have 200. Now we need to, in place of the 200, we need to store 700. By storing that 700, we have the connection in between 10 and 99. Still, we need to do some more adjustment. What is that another adjustment? After the 99, next to omega notation. Omega notation represents operation on linked list. Then the next thing like that, in this sense only we can say that the deletion and insertion operation are performed on linked list very easily and efficiently. Now the next thing we are going to discuss about that, what are the different types of linked list based upon the number of link fields in a node of presentation. Okay, single linked list already I have given. Here we have only the two fields. One is information and another one is next. Information is used for storing data, any type of data. Next is used for storing an address of next node. Then go for a doubly circular linked list. Already I have given. In double, understand this is entire demonstration regarding to the first unit of data structure. I have discussed about three topics: asymptotic notations, arrays, drawbacks of arrays. The drawbacks of arrays are overcome by using linked list, and what is the definition, what is the memory representation, what is the operation, and what is the applications for arrays and linked list. This is the entire information regarding to the first unit, and I'm very thankful to you. Okay, bye.